Okay, so in the last lecture, we have seen the complements, right? And specifically, we have seen the complement for a decimal, tens complement and nines complement that we have seen. And after that, we have seen subtraction of unsigned number, right? Using R's complement. And then we have seen the three different ways to represent a number, right? Sign magnitude, one's complement representation, and two's complement representation. So that thing we have seen. Now we have seen this for unsigned number, right? Using complement. Now here we are going to see the addition and subtraction with sign magnitude, right? Means there is a sign associated with the number. Okay, now in this table, you can see we will understand the table first, right? Then it's easy to understand the flow chart of it, right? So this four
Sir, your screen is not visible.
slide is not visible. Okay. Okay, I forgot to say. Okay, thank you. Now in this table, so we are going to see addition and subtraction with sign magnitude, right? Now in this for addition and this is for subtraction. So for add and for subtract. Okay. Now for addition, when you are performing addition, if the sign of two numbers, right, if sign is same, then what you need to do? You need to add those number A, B. If sign of two numbers same for addition, you need to add those numbers, right? Keep in mind that for sign magnitude represent, we keep sign differently and the number differently. Sign માટે અલગ એક બીટ રાખીએ છીએ આપણે, right? So we are adding those number a plus b when if you are performing addition and the sign of two numbers are same, positive or negative. After that, if you perform the addition, after that, what will be the sign of result? Just keep the sign of result as same as a. J ની સાઈડ છે એ જ રાખો. Okay. Now this is for addition, right? Same way for subtraction. In subtraction, if the sign of two numbers are different, here a scenario કહ્યો તો sign are same in addition. Here if sign are different in subtraction, then you need to add two numbers. Right? In subtraction, if signs are different. Okay. What will the sign of result? The sign of result, that will be your, whatever the sign of a you have, that will be sign. Okay. This is for subtraction. Okay. Okay, so now out of 8, 4 condition now we know. Okay, addition માં same sign હોય ત્યારે અને subtraction માં different sign હોય ત્યારે. Now in addition, if I have a different sign, then so there will be two conditions. If a greater than b, a less than b, or it can be same. right? So in such case, A, B, what you need to do? You need to check A is greater than B. If yes, then you need to subtract B from A. So A minus B, right? If signs are different in both the case, then if A greater than B, then you need to subtract B from A. B from A. The difference will be sign. What will the sign? The sign will be of A if A is greater than B. Any sign of. If A is less than B, if A is less than B, then you need to subtract A from B. You need to subtract B from A. B from A. Okay, so B minus A. B minus A in both the case. If addition signs are different, then and if A is less than B, then you need to subtract B from A. B minus A. The sign will be complement of A. J any sign J, sign of A, એનું complement હશે. Here same complement of A. So here it's a negative means 1. Complement of it is 0, right? Complement 0. So 0 is positive. Now this A is equal to B. Why this thing? To avoid a minus 0, right? To avoid minus 0. કે પછી આવું ના થઈ જાય minus 0 આવે. If this is the case, B minus A બંને equal છે, right? અને or this is the case કે equal છે તો A minus B કરો સેમ છે 0 આવે minus 0. આવું ના થાય એની માટે આ વસ્તુ રાખી છે. The sign is positive, just subtract A minus B. Okay. For subtraction, right? If A is greater than B, then subtract B from A. And the sign is of A. So આ વસ્તુ શું હતું? Addition sign same and subtraction sign different. તો same વસ્તુ થતી હતી. Here in addition signs are different. In subtraction signs are different and A is greater than B, then same thing. A minus B, what is the sign? Sign of A. A minus B, what is the sign? Sign of A. Same way, if A is less than B, same thing, B minus A, and now complement of sign of A. જે વસ્તુ કરીએ same way, B minus A, complement of this sign, so plus. Okay, and this is to avoid minus 0. Okay. So same thing what I just explained you, that is written over here: addition algorithm, subtraction algorithm. Okay, and just choose the sign of result to be the same as A if A is greater than B, or complement of A if A is less than B. So this is the table for sign magnitude, addition and subtraction. When you represent your number in sign magnitude, this is the case. Now we'll see the hardware implementation and the flowchart of it. Okay, so we'll store the number in register, right? That magnitude, and we'll hold the sign in another. We are storing in 1 bit, so that is flip-flop. Okay, so in AS we will store the sign of A, right? If it is -7, then we'll store that sign in AS and 7 in this register. Register is also made up of flip-flops. Okay, same way for B, another number. Okay, we'll do the same thing. The result we are going to store in A and AS. બંનેનું એડિશન સબટ્રેક્શન જે પણ થશે અલ્ટિમેટલી રિઝલ્ટ આપણે શામાં સ્ટોર કરશું એ એન્ડ એએસમાં. ઓકે, નાઉ ફોર પરફોર્મ એડિશન. To perform addition we require parallel adder. What is parallel adder? Parallel adder is made up of full adder. Okay, and full adder means you can add carry as well. Half adder you are using 2 bits, no carry, but full adder you are using the carry. Okay, and the parallel adder that is made up of full adder. Okay, it will take the carry. Parallel adder means there is a carry in for parallel adder and there is a carry out. So this is the carry out and here will be carry in. Okay, now this is the addition, and remember that for subtraction as well, if you remember the unsigned number, to perform the subtraction operation we were using addition only, right? We were not subtracting. What we are doing, the number m as it is plus 2's complement of n, right? If it is in binary, or in tens complement if it is decimal. Then we are checking the carry, discard the carry, or take the tens complement again. So that we have seen subtraction operation, right? So we are converting that subtraction into addition. So we don't require any subtraction kind of thing. So using parallel adder only, we can perform that. Okay. So if we perform addition, then you can directly write a plus b. And if you want to subtract and suppose a minus b, then you can have a plus, we are representing in binary, so a plus 2's complement of b, which is a plus b bar plus 1, right? If you add 1 into 1's complement, complement only means you are changing the number, opposite law. So opposite લઈએ છે શું છે 1's complement, so we are adding 1, it will give a 2's complement. So the same thing we are going to do here. Okay, the output carry we are going to store in E. Okay, there is an overflow flag. There is an overflow flag. Why? So when you perform addition, જ્યારે પણ તમે કંઈક addition perform કરો, at that time overflow may occur. Means you are not able to represent your number in given bits. So suppose 1 sign bit and 3 for your number. So in this case, if I need to represent number, so which number I can represent? So this can be 1 or 0, 0 or 1, right? So minus sign, plus sign, 2, and this number. What is the maximum value? 1, 1, 1. If it is, this is the 1, 1, 1, 1 will give you minus 7. If it is 0, then this will give you plus 7. So minus 7 to plus 7, this range you can represent in this 4 bit, right? 4 bit, 8 bit register and 1 for sign bit, right? If after performing addition, if your number exceed this, આનાથી વધારે થાય, suppose plus 12 result આવ્યો, then your register cannot store this result. એ કેસમાં A2 means error નહીં આપે, but એ નંબર શું કરશે? +7 છે તો એ રાઉન્ડમાં જશે +7. Then let me write -7, -6, -5, -4, -3. So +12, +7, +8, +9, and then +10, 11 and +12. So it will represent -3. અહીંયા -3 આપશે and get circular connection, right? So in that case we need to check this overflow. કે overflow નથી થયો ને, means the result that you cannot store in your register. પણ આપણે હમણાં બધા નાના કેસ જોઈએ છે. રજિસ્ટર જે છે 32 bits, 64 bits ને એ બધું હશે. So means actually in your computer, if you are means performing a complex calculation, at that time this overflow bit and that is useful, means in supercomputer and all. Otherwise in our normal computer, that is not much impact of it. કારણ કે એટલું આપણે પરફોર્મ નથી કરતા. ઓકે. Then we require complement because here you can see આપણે કંઈક કોમ્પ્લિમેન્ટ કરીએ છીએ અને પછી આપણે 1 પણ એડ કરવાનો છે. Right, so how you can do this? So, and this is one way, means this is one thing, and another thing is we just need to pass b. કશું કોમ્પ્લિમેન્ટ કર્યા વગર ડાયરેક્ટલી આપણે પાસ કરવાનો છે. So in this case b is passed to complement અને દરેક વખતે ધારો કે કોમ્પ્લિમેન્ટ કરે તો પછી આ વસ્તુ તો આપણને મળે જ નહીં, right? That will not get. So what we need to do? So we need to say sometime that when to perform complement and when we need not to perform complement. So suppose here 0 આપો means complement perform, don't perform complement, directly pass the b. Okay, to complement means it will not perform any complement, it will store b as it is. The register a is passed to parallel adder. We are giving 0, so it will not perform any complement, so directly b will be added here. B will be added here, and then addition of a b will be performed. Now this is parallel adder and it is made up of a full adder, so there is some input carry. There is some input carry, and here input carry is 0. Input carry is 0. So what it will do? It will directly perform this sum a plus b. If input carry is 1, so what it will perform? It will perform a plus b plus 1. But input carry is 0, right? And we want 0 both the time, means we don't want to activate the complementer, and we want to give input carry 0, right? So we are giving 0 and 0. Okay. Now this is done. For this, what we want? A plus b bar means complement plus 1. So now instead of 0, if you write 1, means this is the same, so here also you will get 1. So now check b register, complement is active, complementer is now active, so it will complement this, and that result will be given to parallel adder, means now here it is b bar, right? 1, so it's a b bar, this will be a, so a plus b bar, parallel adder will perform that, and the input carry, that is 1. So now it will perform a plus b bar plus 1. હવે આ perform કરશે. Okay, and the result will be stored in a only. આ perform કર્યા પછી result ક્યાં store કરી છે? આપણે a માં જ. Okay, output carry જે પણ અહીંયા parallel માં output carry આવશે એ ક્યાં transfer થશે? E flip flop માં. Okay, and this can be useful to check the magnitudes of number, means કયું greater than છે કયું less than છે એ અહીંયાથી check થશે E થી, right? And overflow bit holds the overflow bit when a and b are added. So when we add a and b, ત્યારે આપણે જોઈશું કે આ overflow bit શું use થાય છે. Okay, so this is the hardware requirement. You require 2 registers a and b, and this is the sign bit as bs, means you can use a flip flop, right? So flip flop holds 1 bit. Register made up of flip flops, જેટલા બધા તમારે બીટ જોઈએ એટલા flip flop જોઈએ. Then your overflow bit, E bit, your parallel adder, complementer, and this is a mode control, so we can pass 0 or 1. So this is the hardware implementation of your addition and subtraction for sign magnitude representation. So means when you, there are 2 ways. First, a register will go in parallel adder, sometimes it will get the result from parallel adder, so we need to say કે ક્યારે result એ register ની value parallel adder ને આપશે, and when it will give the result from parallel adder to register. Okay, so that's why we have another, that is load sum. So at that time it will be this thing will be activated and it will store the sum. Okay, mode bit I already explained you. Now the hardware algorithm છે જોઈને એવું લાગે કે આટલો મોટો, but it's a simple thing. જે વસ્તુ આપણે કરી છે એ જ વસ્તુ અહીંયા ફોલો કરશો, it's easy thing. Okay, બે વસ્તુ છે, subtraction operation, addition operation. Okay, so A minute and B subtract, A augment and B addend. ખાલી નામકરણ કર્યું છે, otherwise you can directly store AB. Now the first step in both the algorithm to perform the XOR between the sign. જે સાઇન છે એમાં XOR પરફોર્મ કરવાનું છે. Why? કારણ કે અલ્ગોરિધમ જે આપણે જોયું table. So in table, for subtraction, if it is a different sign, then plus. And for addition, if it is a different sign, if it is the same sign, then addition. So same thing I want to check. That's why first I am performing the XOR between AS and BS. તો અહીંયાથી મને ખબર પડી જશે કે સાઇન સેમ છે કે ડિફરન્ટ. Why? Because if you remember the two table of XOR for same bit, so if you assume this is a sign, so plus plus, if the same sign output is 0, negative negative, same sign output is 0. For different sign it will give output 1, right? So for subtraction I will perform the XOR between sign, and in subtraction, so if you perform XOR, result will be 0 or 1, right? So after this, if your result is 1, result 1 આવે, what is the meaning of this result 1? Sign are different. We are performing XOR on sign ASBS. So if you perform that and you will get the result 1, means both the sign are different in subtraction. So what we need to do? We need to perform addition, A plus B. We need to perform addition, A plus B, right? And when you perform that A plus B, the result will be stored in A, right? And the carry will be stored in E. Right? Now in this, after that, what you will do? Overflow to E. So we'll indicate that overflow. Right? Okay. This is done. And another thing, we have not do anything with the AS. That is the sign. એને આપણે કશું અહીંયા કર્યું જ નથી. Why? Because we are directly taking the sign of AS. And ultimately our result is A and AS. So we have not done anything with AS. જે એની સાઇન હતી as it is જ આપણે લેવાનું છે. કેમ? Because subtraction and sign are different. Then you need to perform addition, right? You need to perform addition, and then the result is A and AS. Now the same thing for addition માટે જોઈએ. So in addition, if both the sign are same, so both the sign are same means output is 0 of AS and BS, exclusive or of AS and BS. So exclusive of AS and BS, output 0. Then you need to perform addition. So જે ટેબલ હતું એમાં જે ફર્સ્ટ કોલમ એ મેં તમને અહીંયા કીધી ફ્લો ચાર્ટમાં, right? So same addition, the result of addition will be stored in EA. Overflow will be set to E. So એમાં 0 હશે there is no overflow. If it is 1 means overflow, means you need to check the result, correct check anything. Okay, and your result is in A and S. So AS your sign bit and your a combination જે હશે તમારું result આપશે if there is no overflow. Okay, if first column પતી ગઈ, right? In addition, if both the sign are different, if both the sign are different, let's do it. Yes, in addition both the sign are different. Addition, both the sign are different, so we need to check the magnitude a greater than b or a less than b. A check કરવાનું છે, and then we will do subtraction a minus b and sign of a, b minus a, and then sign of complement of this sign. Now we'll see that thing. Addition as bs exclusive or is 1 because sign are different, right? You are getting 1. Okay, the first step you need to perform a plus b bar 1. શું કરે છે? a minus b, they are performing, right? So here there is question, why not b minus a, right? Then solution છે પાછળ. So a minus b, it will perform, result will be in a e. This is a subtraction, there will be no overflow bit set to 0. Subtraction માં overflow ના થાય. Okay, then it will check the e, જે અહીંયા e bit છે a. અહીંયા e ને આપણે overflow માં આપતા હતા, but here we are setting overflow 0. Why? Because this is a subtraction માં overflow ના થાય. Overflow ક્યારે થાય? addition માં જ. Okay. Now e, if the value of e after subtraction, right, is 0, value of e is 0 means a is less than b. Value 0 હશે, e ની value means end carry જે આવે છે, તમે 3 bit 1 2 3 1 2 3, right? So this is a, this is b. When you subtract this, the end carry, જે last માં end carry આવે છે, we are talking about it. We are talking about that end carry. If that end carry is 0 means કંઈ નથી. So in this case a is less than b, means b is greater than. b જે છે એ larger value હતી. If e is 1, means a is greater than equal to b, right? અહીંયા એક વસ્તુ આવી ગઈ, કઈ? a less than b. So this is for a less than b. Now this thing is a greater than b, so it can be a greater than equal to b. So it can be a greater than b or a equal to b. બંને condition હોઈ શકે, right? Okay, so for a less than b, a ની value નાની છે, so actually આપણે શું કરતા હતા એ કેસમાં? b minus a કરતા હતા, and જે a ની સાઇન હોય એને કોમ્પ્લિમેન્ટ કરીને મૂકતા હતા, જે પણ સાઇન હોય, right? Complement. So એ જ વસ્તુ અહીંયા થાય છે. How? So what it will do, it will take the complement of a, રિઝલ્ટનું કોમ્પ્લિમેન્ટ લઈ લે છે, રાઈટ? સો એનું કોમ્પ્લિમેન્ટ લઈ લીધું, એન્ડ એમાં શું એડ કર્યું? 1. એટલે શું થયું? એનું કોમ્પ્લિમેન્ટ લઈને એમાં સ્ટોર કર્યું એન્ડ એમાં 1 એડ કરીએ, રાઈટ? This can be done using parallel adder. So if you perform this, then you will get 2's complement of your number. 2's complement of your number, right? And then we will complement the sign of as, and then we will complement the sign of as. Actually आप a minus b કરીએ એટલે શું કરીએ છીએ a plus 2's complement of b આ જ વસ્તુ કરીએ, રાઈટ? અને રિઝલ્ટ સ્ટોર થશે, આનું જે પણ રિઝલ્ટ હશે સ્ટોર થશે સામાં e અને a માં. a માં એ રિઝલ્ટ છે, a માં એ રિઝલ્ટ છે. હવે એનું 2's complement લઈ લઉં તો મને આ જે રિઝલ્ટ મળશે એ મળી જશે, રાઈટ? We will take example as well, right? We will take different example as well, and એ example solve કરીને આપણે જોઈશું આખું flow chart માં. Okay, and then complement of sign જે આપણે કરીએ છીએ, right? That will be your result, as and a. Now if the value of e is 1 means a greater than equal to b, so આપણે check કરવું પડે a greater than b or a is equal to b. So how you can check? If a and b both the values are same, તો result જે a હશે result a result એમાં શું આવે value 0. If a and b both are same, so result will be 0. So you can check if a is 0 means a is equal to b, a is equal to b, right? So એમાં આપણે ખાલી શું ધ્યાનમાં રાખવાનું છે કે સાઇન result 0 આવે એ fine, but the sign negative ના આવી જોઈએ. So what we are doing, we are just changing the sign, or we are making sure that a sign positive આવે, right? So a is 0. Here you can see a result, this is 0, and your sign as is 0, so positive 0. Okay, if a is not equal to 0 means a is greater than b, a is greater than b. And if a is greater than b, so what? So simple, a minus b and then the sign of a. એવું છે ને ટેબલમાં જો આ વસ્તુ હોય a greater than b, this is a greater than b, and this is a equal to b, and a less than b. Okay, so in this case a greater than b, આ ખબર પડી ગઈ કે આ a greater than equal to b માંથી બે માંથી કોઈ વસ્તુ છે, અને અહીંયાથી a ચેક કરીને એ પણ ખબર પડી ગઈ it is a greater than b or a equal to b, equal to b, right? If it is a equal to b, result is already 0, just we need to take care of the sign. If a is greater than b, so a minus b we have performed, and the sign of as, so that is also there in as. We have not done anything with that as, so our result will be as a, right? So this is the flow chart. This thing for addition and subtraction, this is the first column of table, right? For addition, both the sign are same. For subtraction, both the sign are different. Then you need to perform this addition, just set e to overflow, and if there is no overflow, then your result will be in as and a. હવે એના સિવાયની બાકીની જે condition છે, out of 8, 4 condition will be solved by this. Remaining 4 એના માટેની આ બધી વસ્તુ છે. So for remaining 4, you need to check a is less than b, a is greater than b, or a is equal to b. Okay, so this is a flow chart of the hardware implementation. જે આપણે hardware implementation કર્યું એમાં કઈ રીતે subtraction ની વસ્તુ perform થાય એ વસ્તુ આ flow chart માં છે. Now any doubt in this?
No, sir.
Okay. So in next lecture, what we'll do, we will trace this algorithm, or not algorithm, we trace this flowchart. Okay, with example. So in next lecture, I will explain you by taking the example how this flowchart will work. Okay. So we'll end our meeting here.